Hi, Kai. How are you? How are you today? I still see muted. You want to click that button on the bottom of your screen.
Okay, I'm sorry. Yes, now.
It's great to see you. Thanks for being here. I have your slides. I'd love to give you a little introduction. For everyone joining us from room 1, we will have 3 talks in this room this morning, well, in our first session of today. First being Kai, who is here with me. He'll be talking about porting user applications to Qt 6. So welcome, Kai, and thank you again for being here.
Thanks for having me. It's a great pleasure to be once again on an academy. It's been a while. So yeah, I want to talk about porting user applications to Qt 6. So the focus is a bit on user applications. You heard yesterday, if you have been joining yesterday, an update about the KDE frameworks and that they are also working on this and so on. But this is not, the talk in that sense isn't KDE specific, because to be honest, there would be others who would be probably much more into the current state of things. But kind of what it takes in general to port a Qt 5 traditional application to Qt 6. All right. I hope you can all hear me fine. If not, scream. So yeah, when preparing the slides, actually on Friday, a colleague kind of a completely different presentation talked to me and said, all the technical presentations often miss the why. So I was adding this this slide on last second. So why Qt 6? Why porting to Qt 6? To be honest, Qt 6 is in a lot of ways just a logical conclusion or going forward from Qt 5. So from times to times inside Qt, we just decide, okay, there is enough architectures to be changed that we don't really want to do in minor changes, minor patch sets. There is enough, deprecated API now that we want to do a clear cut and actually get rid of deprecated API. And also do just architectural stuff like updating the C++ version and so on. And then it's kind of the discussion starts, and then we say at one point, okay, that should be actually a next major version. So in that sense, it's like a logical conclusion from Qt 5. On a very high level view, what we want to aim with Qt 6, what you can expect also in the next years to come, is, well, I mean, the world is changing. We are looking to new platforms. Also architectures, like the whole macOS and ARM thing is going on. The other side of the coin is graphics. There is a lot of development there where, for instance, I don't know, with Qt 5, we did a bit of a bet on OpenGL, and the whole Qt Quick story was built on top of OpenGL. Now we are in a completely different landscape where there is Vulkan and Metal and probably more DirectX coming and evolving. So that also requires some bigger changes inside Qt. Qt Quick is an ongoing thing since years. Also, since Qt 5 released, we have been learning a lot how to also write bigger applications with Qt Quick. The challenges that comes with that, with the current Qt Quick integration in terms of tooling, in terms of maintaining bigger applications. So there is a lot of going on there to make this better. And yeah, on the strictly C++ side, there's been discussions about whether our current containers are still good enough, how to want to evolve them, that we have some API that we, don't want to advocate anymore or let people use anymore, and so on. So that's all good reasons for Qt 6. If you are interested in particularly that, like the bigger picture, I can only refer you maybe to the talk by Lars Knoll next Wednesday, I believe. Where he will be going into details about this. So I want to kind of focus more on a very practical, okay, let's get it done, let's take an application and port it aspect than the bigger picture. Fair enough. So the next couple of minutes, we will quickly have a look at the current state of Qt 6. Then what it takes in terms of build system and CMake integration to port an application from Qt 5 to Qt 6. And also the C++ side was already hinting at containers and so on. What does that mean for me, for my application? And tooling available to help you with the transition. So yeah, Qt 6.0 got released last December, which I was personally quite happy about because it was actually, almost or very near the original scheduled date. If you look big into Qt history, that wasn't always the case. So I think we did a good job there. Early on in Qt 6, though, we already decided that we kind of can't cope with porting all of the Qt 5 modules to Qt 6 at the same time. Qt has been growing over the years. And, it's just, from the timing and quality and effort perspective, very challenging to kind of tackle all these modules with the existing people working on it. So we said with 6.0 we want to kind of port the most important modules, the modules we consider most important, and then quickly follow on in minor versions to also port more. So that's what you see here. Qt 6.0, there was already quite some modules in 6.1 that's released in May. We did do a couple of minor ports, and another big chunk will happen with 6.2. And there is this saying now that, and you often read people that saying, no, 6.0 is for this reason alone, just technical preview, and you can't use it, and so on. I don't agree. I think the quality of 6.0 and 6.1 is actually, there's always things to improve, and I'm not saying there is not any regressions, but also looking a bit in history, I think it's actually fine. Have been doing a good job there. The community has been doing a good job there. Yeah, but obviously, if you depend on Qt Multimedia, I think was raised yesterday in the chat and the discussions, then you might need to wait until 6.2, which is currently scheduled for September. So the very first thing you might want to just check out is kind of the list of dependencies you have and check what the state is there. So with that in mind, let's move to the build system. So very practically, I assume you're using CMake. You're having an application that's working fine with Qt 5. What do you have to do to port it to Qt 6? So yeah, I mean, this is typical API that you will see in Qt 5 with Qt applications building against Qt 5. So CMake, you start usually with a find package and actually saying, what actually I want, like in this time it's Qt 5 with Qt widgets. Then you have APIs like where you directly might want to call functions that are provided by the Qt modules. They usually start with the Qt 5 underscore. And in the end, you're also using the targets that were imported by the find package to, for instance, link against Qt widgets. And again, you have a big Qt 5 there. So you can already see that if you compare it, for instance, to C++ API, the CMake API is very versioned, which is not a big problem for a very straightforward port because, you can just go on and mass replace Qt 6 with Qt 5, Qt 5 with Qt 6, maybe in a separate branch, and suddenly you're golden. And that's really how it works, right? So we haven't changing much in the names of modules and so on. There might be some smaller things, but overall, there isn't that much changes in the CMake API compared from Qt 5 to Qt 6. So most of the things will just work. Anyhow, this has a problem in that you are now having two different versions. And unless you really want to kind of, do a one-off port or so, you often have the requirement that you want to support Qt 5 and Qt 6 at least for some time by the same code base. So what do you do there? We had a look. We had problems ourselves. So we already in 5.15 we have been looking into this. And added some new API. So that's a very canonical solution if you want to support only Qt 5.15 and future Qt 6 versions. So what has changed here? First of all, you might notice that there is two different find package calls. What's that? So the first call is actually using the names argument from find package, which is I don't think that often used, but the idea here is that I tell CMake to look first for Qt6 package, and if that fails, and for instance the widgets are not found, then look for Qt5 package definition. And CMake has all this kind of a bit weird ways to locate packages. So that sounds exactly like you want, right? We want to say first Qt6 and then Qt5, and then work with that and store that into a component, a package called Qt in this case. That should be enough, but to be honest, it doesn't work out of the box because, for instance, even the auto RCC inside, or auto mock was it, I think, inside CMake support doesn't work with that. So it expects that the package is called Qt6 or Qt5. So what to do there is basically just using that first call to basically determine the major version that's stored into a CMake variable called Qt_version_major, and then use that argument to actually load the real thing, so that we are having again a defined package Qt5 or Qt6 here. So that's straightforward. Another change you see here is that we have been actually calling something, a function here, that is the CMake function that's defined by Qt without a major version. So not Qt5_, but just Qt_. So that's an alternative API we've been adding in Qt 5.15 for all the functions that are exposed by the Qt modules to kind of help in the porting. And that's actually also true for targets. So you can also just refer to Qt__widgets, and it doesn't matter whether it's target imported by Qt 5.15 or Qt6. So yeah, the big thing to remember here that's API that we only added for 5.15. So if you want to support even older Qt versions, like Qt 5.14, then it looks a bit more complicated, but still manageable. So in this case, you can't rely on the unified function names. So you have to basically always do the checking, am I Qt5 or Qt6? And also the targets. In this case, you can just use the Qt version major variable as a target. Good. What else to remember? Well, I already hinted that Qt6 is requiring C++17, so that might be a good idea to check whether you are also requiring that, or maybe you're already requiring a new version. I don't know, but yeah, it's a good check to do, that you might also want to bump your C++ standard requirements. And the last thing about CMake that I want to mention is that there is a new module called Core5Compat, and the name says it all. It's a a library module which contains some of the API that we removed from Qt6 core specifically. So for any non-trivial port, there's a good chance that you actually want to include that thing too. Obviously, only if you compile against Qt6. But we will come to examples about this in a second. So the summary goes, yeah, my recommendation is for commands that you want to use from Qt, if possible, just use the unversioned ones. I think we should go on with them and actually make them default. So that, for instance, the Qt6 to Qt7 port won't have that problem anymore. The alternative also for targets is to use just, check or embed Qt version major variables so that you can support both Qt5 to Qt6 and the C++17 requirement that I mentioned. Good. To be honest, I don't hear anything. I'm not even sure whether people listen. So maybe that's a good point where if there is already questions. All good? Okay, good. Then I will just go on. So yeah, so this is about basically assuming that you're having a more traditional application and you want to port it, then doing the build system change, and then you most likely will run into still some compilation issues. So that's somewhat to be expected. But obviously what exactly it is depends largely on the application. So what we have as a test bed, what we can offer as a case study is actually Kit Creator. So Kit Creator is our IDE. It's actually a large application. It uses a lot of the modules in Qt, though, I mean, obviously it's like, for instance, Qt Multimedia, I think, is not used. So there is exceptions. It's a certain type of applications. You have that problem always with case studies. Anyhow, it's, I think, a good idea to start looking into that. So what we did is already quite early in the Qt 6 development to try to make the current Creator code base compile also with Qt 6. So that we can learn from it. Also, we provided feedback so that, for instance, some of the changes weren't done or were reverted and so on. So that's kind of also the role of Qt Creator, to be a bit like the test case there, if changes are acceptable or not. So I set the same code base, so it was not kind of a one-off branch or anything like that, but we always want to support multiple multiple Qt versions with Qt Creator, and Qt 6 is not an exception in that. So in that sense, it went on a bit in parallel with the normal development of Qt Creator. What we did, though, very early on is kind of trying to collect all the changes that are somewhat related to the Qt 6 port into one item in the bug tracker. So if you want, you can look it up. We're talking about roughly 180 patches there, which sounds a lot, but on the other side, most of them are also very small and so on. So it was like, there was no big, I mean, I convert everything to Qt 6 commit, but rather, module by module and case by case, or in a lot of cases. So what I did as preparation of this talk, I was actually kind of, going through the list and trying to categorize the things a bit more. To see actually whether there is patterns, and some of the things was obvious, but some of them things even surprised me a bit. So that the result of this is on the right side. So yeah, I was basically going through the patches and saying, okay, this one was solely for fixing Q-linked list, for instance. This one was affecting also, I don't know, some other use case. This one was for regular expressions or regex. So what you can see here is a bit of a pattern that, yeah, there is like the largest bar, that's QRegexp. I will, for the most important parts, I will have follow-up slides. So we will look into this. QString, QCharef is another case which might be interesting. Then there is a whole set of things, around containers. So let's also have a look at that. And the second largest one, I don't know, other is obviously a bit of a basket for everything, but replace API deprecated in Qt 5. That was actually something that I can kind of recommend in general. So if you want to port your application to Qt 6, the best thing probably to do is first port it to Qt 5.15 if you are not building with Qt 5.15 yet, and actually deprecate, fix all the cases where you have API that and use API that's already deprecated in Qt 5.15. So if you haven't done that already, there is a nice define called Qt disable deprecated before. And in this case, that's hex for 5F, that's 5.15. So it says Qt remove all, or rather pre-compiler, remove all the declarations of API that is deprecated in Qt 5.15, and then you will get compile errors if you're using them still. So yeah, I can only recommend that because that catches already a lot of cases. So, but let's look into some more interesting topics probably than just smaller deprecations, because a lot of them are really straightforward, and the documentation usually just tells you what to use instead. So QRegExp, that was the largest bar, if you remember. So what about that? QRegExp is the way to handle regular expressions from Qt4 to Qt5 times, basically. So yeah, the class is heavily used in Qt Creator, which is, might be a bit IDEs are all about text manipulation and so on. So that might not be a complete surprise. And we've been using QRegExp heavily in hundreds of places. But already in 5.0, there was a replacement for QRegExp. So QRegular expression was introduced back then. So yeah, but we never managed to do the port, basically. We had cases where we had QRegular expression, but we had also lots still of cases where we had QRegExp. One of the reasons might be, well, it was just working, all right, fix code that just works. The other one is that the porting it's not just a single, text replace. So that's a bit like, if you know the architecture of QRegExp a bit, it is both a representation of the regular expression, but also, for instance, a representation of the results. So it was a bit of a mixture there. And with QRegular expression, we've been splitting up into two classes, QRegular expression and QRegular expression match. That's one of the examples, and there is a few more in that regard. One thing, there's kind of a bit of a gotcha, that's why I'm mentioning it, is that, for instance, also the wildcard syntax is not exactly the same. So QRegular expression uses a different backend for that. And in general, it has more features, more advanced features, handles Unicode and whatnot. But it's also a bit stricter. So you might have a regular expression that is working as a string. You pass it to regexp, and it's not working anymore with QRegular expression. That's not very often. I mean, the common set of regular expressions are the same. But if you're using some features and relying on some more obscure details, then you might hit that. The problem with that is your compiler won't find it, right? It's just a string to the compiler, so you don't get a nice compiler warning. You get just different behavior or crashes even, depending on the result of this. So that's a bit of a gotcha. Remember, maybe checking the regular expression and maybe putting a bit more effort into checking that it still works as expected. That's also true for another case, which is kind of using not actually per regular expression, but wildcards, like you're using from the shell. So also there, QRegExp had directly supported this. QRegular expression doesn't, but it has a static function which you can call to convert a wildcard expression into a regular expression. That works also, but there is also some smaller details to remember, for instance, when it comes to slashes in the string and so on. These are all, by the way, very nicely documented in the porting guide. So if you want to know details about this one, I would actually recommend going to the porting guide. I just want to mention another kind of slight difference, which is a bit annoying. It's like that you had QRegExp matched length, and okay, I just see an error. It's actually QRegular expression captured length. And these sound like almost identical, but the return value, for instance, for the case where there was no captures is different. So in the one case, it returned -1. In the other one, it returned 0. That's an example. It's a bit unfortunate if you kind of just mass replace things and suddenly things don't work anymore. So again, I have to say we had lots of cases of QRegExp in Qt5, in Qt Creator, and most of them are really straightforward to port. I could open now the browser, but I'm not exactly sure how this works here in this in this chat. So if you're interested, we can also look it up later. That should be it for QRegExp. So remember a bit to take special care there that actually it works the same as before. Another of these cases is QStringRef. So what is QStringRef? It is an optimization that you can do already in Qt 5 times, maybe even Qt 4 times, I don't remember, where you want to have a look at, you want to analyze a string, a QString, and you want to kind of have parts of it, for instance, for further processing, but you'd want to avoid the overhead to kind of copy and paste that, because QString will then allocate a completely new object and so on, and when that might be expensive. So QStringRef is an optimization for that, which is available in certain classes and of Qt, and is exposed there, and you could use it to work with substrings, basically, of underlying strings. So being, again, an IDE, Qt Creator was also making heavy use of that. What happened now is that in Qt 5.10 already, so already like, a couple of versions ago, there was a proposal for an alternative API, which is considered superior. That goes under the name QStringView. The very same concept, a bit of a different implementation, and also much more generalized. So QStringRef was only really working for QStrings. QStringView you can also use for, I don't know, standard 16 strings and so on. So it's a bit decoupled from the QString implementation. And it's also now available in lots of other API, like in Qt Core, where QStringRef was kind of limited in terms of Qt API that's exposed there. There's also, for instance, now also a Qt byte array view and so on. So the concept is a bit more generalized. So in general, it's recommended to use that, and that's the reason why we removed QStringRef from Qt Core. It moved to Qt 5 Compat, but the problem is that, again, the API, you're not using often QStringRef alone, but you're using it with some API that exposes it. So in Qt, and these APIs also can. So it's time to port. That's at least what we did in Qt Creator. Small gotcha there, again, not that common, but there is a bit of a different behavior when you're using a view on a string and then change the string underneath. So it might be obvious that that's not a good idea to do. And the thing is that QStringRef was trying to fix a couple of cases there, while QStringView does not. So again, we had one case, I think, in Qt Creator where this led to a crash, just to let you know. On with containers. So something that's a bit annoying, I have to say, is QHash versus QMultihash. So a QHash, right? The structure, it's a key value thing, and the container is optimized for looking up the value by key. And then there's also the idea to have that also as a multi-hash, which means that there is one key, but there might be multiple values. So in Qt 5, that was a bit of a weird setup because there was QMultihash, but actually the implementation was in QHash, and you could actually use QHash as so QMultihash was derived from QHash, was added convenience functions, but the implementation was, or the logic was in QHash, and you could use a QHash as a multi-hash by just using explicit API like insert multi. So it was a bit of a mix of concepts, and in Qt 6 it was decided to split it up and have two template classes, QHash and QMultihash, which I think makes complete sense. But if you're porting, you might have cases where you having a QHash in your API, and you actually have to decide, was it meant to be a multi-hash or not? So in that way, it's now more explicit, but that's something that you can't kind of automatically decide. Obviously, if you have a header file somewhere and it takes a QHash, then you have to decide whether it should be rather a QMultihash. So that's one of the things where which you can't just automate by search replace. The other thing, again, is like, and I think that's now a common pattern, if you see that also the implementation of QHash and QMultihash changed a bit from a node-based approach to a two-stage lookup table. So interesting topics if you're into that. The bottom line is obviously it should be faster now, but it also has some implications in terms of reference stability. So if you have a hash and you take a reference or a pointer to, for instance, a value, and then you change the hash, then that will, well, I have to say, crash more often. So, I mean, even in Qt 5 times, that was a bit problematic, but it was usually working, and you shouldn't rely on that. But that's how it is. You write code and it works, and you keep it. So we had one case there, or two cases, I think, where we had to adapt our implementation, and the solution was to actually go to standard unordered set in this case, because standard unordered set has this explicit guarantee that you can have a reference, and it will only be invalid if the item itself is deleted, or the value itself, or the key value pair itself is deleted. So that might be an option then to use. Now, if you're into containers and have been following the discussion, I don't know, just a bit, then QList might have come and QVector might have come to your attention. So the problem with QList was twofold, or is twofold. The first one is that it had a very interesting implementation in that it tried to be clever whether the elements of a list would be allocated like continuously in the memory, or whether the memory allocated for QList is just an indirection and points to somewhere else in memory. And QList had some try to be clever and determine what you want and what's best for your use case. Turns out that very early on, people pointed out that this is not always work for creating the right results, and that we should rather use QVector, which was added as a very explicit way to say, okay, it's always one continuous block of memory, and the elements are in there, which is faster in terms of memory access. So if you iterate over things, then that's usually the preferred thing. All right, so then there was discussion on what to do in Qt 6. That was one problem, so weird memory model. And the other problem was that there is the STD library, which unfortunately has different names or the same names for different concepts. So they also have a list, but it was actually, they have a list and a vector, and QVector is standard vector, but QList wasn't, standard list, but was something in between. So there was quite some discussion how to solve this. One of the ideas was to, deprecate QList and just live with QVector. The thing is, QList is everywhere. It's in a lot of, there is hardly, well, I'm exaggerating, but it's arguably the most used class of Qt, maybe in line with QString. So changing such a fundamental thing and deprecating it would be really kind of the mere definition of a source compatibility break. So we decided not to do that in the end, but instead adapt the implementation of QList to be more or less that what QVector was previously. So yeah, that's what happened in Qt 6. So if you have still fights with your colleagues about whether to use QList or QVector, the good news is you can stop now, because you can say in Qt 6 it's all the same. QVector is now a type def to QList. And yeah, you might imagine that's quite a fundamental change. To be honest, to my surprise, in Qt Creator, we barely noticed. So there might be performance improvement in some cases, performance degradation in other corner cases, but to be honest, kind of in the overall thing, it really didn't show up too much. So that port was actually quite forward, except that if you are really into pre-declaring everything, like in the headers for optimizing compile times, then you have a problem because QVector has been changing. So it's not its own class anymore. So yeah, another word about reference instability. You might notice the theme now. QList for bigger, for certain types that were large enough, and actually, you could take a reference and to an element, and because it was at a different memory location, you could change the vector, the QList, and the reference was still valid. Not true anymore with QList in Qt 6. So if you're having a case where you, have that problem, or anyhow you disagree that actually the new implementation is better, then the cop-out is to go to standard list, because that is always this structure where you have the elements are stored separately in memory. And if you're using Q-linked list, that was also one where we noticed, okay, Q-linked list is actually standard list from their concept here. It's rarely used, at least in Qt Creator and Qt. So we just decided, okay, let's move it to Qt 5 Compat. Again, you can find it there, but to port it, actually, just use standard list. Good. Yeah, the summary is that porting is mostly straightforward. Yeah, I mean, it might not appear from the slides that you showed, but I was kind of after showing you the interesting things. So most of the patches of the 180 whatever patches that I had was actually quite straightforward. So don't get confused by these footnotes basically that I'm bringing up here. And yeah, the recommendation is port to Qt 5.15, fixed deprecations, then moving to Qt 6 should be actually quite straightforward. But what exactly you're affected with is obviously depends on much on your application. So we were looking to KI user feedback, for instance, and there it's mostly Q-hash. I mean, it's also just a couple of things, but sorry, there was Q-variant. So Q-variant was got a lot more stricter and so on. So what we really try to do, and all I'm telling you is probably documented in the documentation. So there is a porting guide on doc.qt.io that you can go to. And there's also separate pages for every single module, like Qt Core, like Qt GUI, and so on, where the things are kind of explained. And we try to be really thorough with that to help you there. So it's a good idea to either directly read that thing or at least bookmark it if you are actually doing the porting. And yeah, we also much appreciate feedback about this one, to be honest, because I think now is the time to really, cover all this things and so on that people can benefit from it. So, yeah, the last thing I want to mention is that I've been saying a lot of times that it was a lot of mechanical things. So the obvious question is, can't we automate this? And we had the same idea and actually worked together with KDAP and the KDE community on Clazy. So if you haven't used Clazy yet, it's, I think, originally created by KDAP, a tool that is built around Clang and allows like these code transformations, so code checking and code transformations. And what the latest version, which is, I believe, 1.9, features now at least these 4 fixes. So these are not, so Clazy, the whole Clazy had a lot of fixes and checks, but they are split up a bit into, this is really kind of, everybody should use that. So it's in the default set of things to be checked. And then there is Minecraft manual fixes. So that's the category of manual fixes. So if you just run Clazy without any arguments, you don't get them. But if you're into starting a port, then be aware that there's Clazy checks for header fixes when header changed, forward fixes. That was actually also quite often that I don't know, some header was included by some other header, which is not true anymore. Q-hash signature is another one, size T versus int and so on. So I can only recommend to use that. And we'd like to have feedback actually about this, because to be honest, we didn't receive so much about this. So that means either that people are perfectly happy with it, or which I doubt, or they haven't discovered it yet. So talk to us, tell us what you think about this one. I think that's it.
Hey, thanks so much. Well, we have reached time, unfortunately, but you do have a list of questions. I'd love to invite you to the Matrix channel to answer some of those questions in chat if you have some time.
Sure. Yeah, I'll be there.
Great. Well, thank you. I will connect with you also off screen to make sure you're able to get all of the list of questions too. So just ping me and we'll get you all set.
Cool. Thanks a lot and have fun.
Thanks. Thanks so much. Have a great rest of the day.
You too.
Well, everyone, up now, we have Timothy who's going to talk to us about Keynote. I'm sorry if I'm not pronouncing that correctly. And introducing Fedora Keynote. Please welcome Timothy. Are you here with us?
All right, can you hear me correctly?
Hi.
I'm sharing the webcam. And yeah, I'm here. All right, I'm finally here.
Great to have you. Welcome.
Thank you.
I'll let you take it away.
Thanks. All right, thanks. So, hey, welcome everyone. I'm Timothy Hervier, and I work at Red Hat in the CoreOS team, mostly on Fedora CoreOS. And I'll be talking here today about Fedora Kinoite, which is a new version, a new variant of Fedora that we're introducing with Fedora 35. So let's get right into it. So first, the question is, okay, why Fedora? Why even bother with Fedora? And then why even bother doing this at all? And then, okay, where are the apps? Okay, well, with everything, we'll see a little bit about the future and what we want to do with that. So first thing, what is Fedora Kinoite? So Fedora Kinoite, essentially, it's a new Fedora variant, which is attached to the KDE SIG, so the special interest group in the Fedora community. We 100% Fedora, so nothing in Fedora Kinoite is different from Fedora. It's just Fedora, but a little bit of a different twist, and we'll see that coming right away. So yeah, it's 100% Fedora RPM packages, so it's purely Fedora. The thing that's different, of course, we're not just building something else just for the sake of it, is that it's an immutable desktop. We like to call it an immutable desktop, not in the sense that it won't change, but that you control how it changes, which is really important, like keeping control of your computer, of course. And of course, we're here at the Academy. It's all about KDE, and this variant is featuring the KDE Plasma desktop. The first release for Fedora Kinoite is planned for Fedora 35. So right now, Fedora 34 is stable, and we are in the development of Fedora 35, which should be stable something around October or something. Yeah. All right. So why Fedora? Well, there are a couple of things here that makes Fedora interesting as a base for this project. The first one is that Fedora provides a stable and up-to-date software stack. So we integrate a lot of things in Fedora, a lot of open source projects, fresh and but stable open source projects. So we do a lot of work on Wayland. We have Wayland enabled by default, Pipewire enabled by default in Fedora 34, systemd user sessions too in KDE. And all of that comes tested and baked into the image by default. With KDE, more KDE focused, we always try, oops, is it still working? Oh, sorry. Yeah. We always try to follow KDE packaging, following KDE packaging, the latest release of KDE packaging. We try to go upstream first, usually. So we try to make sure that every single patch is upstream first, and that nothing is like only carried by us. We always try to keep it upstream. I'm sorry, I'm having a bit of trouble. I hope you can all still see me and hear me, and that should be fine. All right, so, oh, come on. Ouch. All right, I'll have to ask you to change slides forward, but that should be fine. All right, so yeah, we upstream first, and we are an active special interest group. So we have weekly meetings on Monday at around 1800, and we're fairly active. Right. So what makes it different? So it's a little bit different from the KDE Spin, the classic KDE Spin, because it's based on rpm-ostree. So it's a different technology to manage how you have your system. And essentially, the idea is that instead of managing single packages, you manage an image for your operating system, and you move from one version to the other when you update. It's the same technology that's used in Fedora CoreOS, for example, Fedora IoT, and Fedora Silverblue too. So that's rpm-ostree for managing the system. And then there's Flatpak, that you use to manage applications. So the basics about Flatpak is that instead of installing applications as packages, you install them as different package as Flatpaks, and they can come from different sources. So you don't have to add them from your distribution. You can add them from something else. They could even be proprietary or provided by other vendors, and that's not an issue at all. And finally, when you've got all that, sometimes you have to do development, you want to have command line tools and things like that, and everything on Fedora Unite is using containers, essentially. So to manage containers, we use Podman, which is a container manager, which is very well suited for command line tools. All right, and well, with all that said, the first variant, this kind of variant that was introduced in Fedora was Fedora Silverblue, and essentially we are really close siblings of Fedora Silverblue because we use a lot of the same technologies. We share a lot of them. Okay, so what does it look like? Well, essentially, it just looks like any regular KDE desktop. Like if you just booted a Fedora KDE Spin and you compare it to a Fedora Unite Spin, it's essentially the same. It looks exactly the same because it's the same packages, same software, same configuration, nothing changes except maybe a logo. We don't have a logo yet, but in the next in the coming week, maybe we'll have a new logo, and that will be the only difference essentially. If you look just at the cover at the top. So here it is. It's a Fedora 35 that I recently booted, and you just install apps using Discover, just like on regular KDE. It's just like the only apps. Well, mostly the only apps that you can install are Flatpaks. And you've got the same menu, the same file managers, and everything, same browser. Nothing changes here. All right, so what's the current status of this initiative? Well, the official support is still in progress. So, well, it's working. We already have, it's planned for Fedora 35, the first release. You can track all that on the tickets I linked here. We already have the official development builds. So in Fedora, we call that Rawhide, the development branch, which is like continuing development, and then it gets branched for each release. So in October, a little bit before October, it will be branched for Fedora 35, and then we will get our first stable release of Fedora Unite. So right now it's Rawhide, so it's development builds, but it's working. I also produce an official build. So I produced an official stable build for Fedora 34, the current stable branch. The only difference between the Fedora 35 builds and the 34 builds is that I do the builds for Fedora 34, so it's not signed by Fedora Key, and it's not built on Fedora infrastructure. It's built on my server, essentially. But it's still the same content. All right, so what's the goal behind all that? And what do we want to do behind Fedora Unite and everything like that? Well, the main thing is want to create a really easy experience for users, which I think is like the top one priority. If you don't have users, well, it's not worthy of making anything, well, most things at all, even if it's just you. But yeah, like we want to create a good experience for users. So the first one is we use rpm-ostree to manage to manage a system and make system updates essentially a non-event. The idea is that when you update rpm-ostree, it updates in the background. So you don't change your system live. It creates a new version of the system, and then you reboot into it. And that's the base idea, because essentially you don't have to wait for this to apply. You don't like have to wait for your computer to update before you boot or at the shutdown. You just do like the updates live on the system, and it only take place when you reboot, and you just reboot into the new version. the base itself is also shipped as like one single consistent image, so you don't get like half things installed or half things misconfigured, things like that. It's just either install or not install at all. It's atomic. It's just one or the other. You can get mix. And if for whatever reasons you reboot into the new version and there's a bug, like I don't know, there's an audio bug, a graphics bug, and you just want to go back because it's your day, you don't like you have things to do. You just go back to the previous version, then that's easy. You just reboot into the previous version, it's always there, and you keep doing the work while you try to figure out why the bug is there, report the bug, or something like that. So yeah, that's the system. And RPM-S3 makes managing the system really powerful, and that's the most of it. Then there's Flatpaks. When you use Flatpaks, you get a lot of advantages right out of the box with the way Flatpaks work. So the main idea is that you can install and update applications just like on their own. You don't need to update anything on the system to make them work. All the life cycles of the application is tied to the Flatpaks, and that's it. There's nothing like linked to the system, and it makes it really easy to update application, install new ones without even bothering whether or not it will pull any libraries, if there will be inconsistencies or conflicts or anything. That's never going to happen with Flatpaks. It's either there working or not there, and that's fine. So yeah, it makes applications updates and changes completely independent of system updates, completely independent of the kernel, the changes, and everything on the desktop. We have two main sources of applications with Flatpaks. Right now, we have FlatHub, which has mixed free and open source software and proprietary software. And we also have our own set of Flatpaks built on Fedora infrastructure, which we only contains free and open source software only. And finally, the last piece here that makes it a great experience is Toolbox. So the idea is you have an immutable system. So well, it's not always practical to install a lot of the key tools or command line tools, something like that on your systems. And what you want to do probably is do most of that inside containers. And Toolbox is the best way to make that available. And it also instantaneously makes all the RPM packages from Fedora available to you directly and free of cost, really easy to use. And you can also use Toolbox with other distributions. So essentially, you get all the software that is packaged everywhere inside every single distribution using Toolbox, and you can run them as graphical application on your desktop, and it will work, essentially, in most cases. So yeah, that's like the last result thing, but that usually works for most things. All right, so that's like the basic thing. If we want to make the user experience great for updates, great for install, access to software, you don't get to miss anything, and at the same time you get all the benefits of easy updates, never having fear that something will break if you update. So then, all right, we have users, but most of the times we also try, sometimes even users try and do and test things, and we sometimes want to, as developer, ship some updated software to users for them to test. And that's something that's really easy to do with the same technology. So the main thing is, thanks to RPM-S3, you can actually give updates to your users and have them try them just like one shot or thing like that, and then let them go back to the stable versions. And that's really easy. That's something that is really hard to do with classic package managers, and that's really easy to do with RPM-S3. So you give it, you don't give up stability, and you keep everything working while testing a new version, for example. And that's what you get with RPM-S3. You keeps everything as is, in the sense that you keep all your files, you keep all your software, all the Flatpaks are still there. They're still stable versions. You just standardize the system, and that's it. And you can always roll back if you got any issues. If you want also, if you're a developer, you might be interested. Well, if you're a tester, you might also be interesting to test new Flatpak, new versions of Flatpak apps. And that's something that's really easy to do with Flatpak too, because you can have multiple versions of the same application installed at the same time, and that's not an issue at all. With Flatpaks, you can switch between versions easily and install multiple versions in parallel. So you can always get the testing versions and the stable versions. So if any issue comes back, you can just start the stable one, and that's it. Then another thing that's great that with Flatpak, it's really easy to produce Flatpaks from like PR or GitHub PRs, for example, or any kind of PR essentially. And for example, you could give like create a Flatpak repo, create a Flatpak change, just one change, for one fix, and have it sent to users, and then the users can try this and like make sure that validate that the change is correct, and then you can merge the code. So I put a link to GitHub Action because it's a quick way to try to try and create Flatpaks from that. Right, and finally we have developers. So if you are building on KDE, working on KDE, either the Plasma desktop itself or any applications, this is also a great opportunity for you because rpm-ostree makes you keeps you in control of what's changing on the system. So it enables control chains. I like to say it's immutable, but you have control over what changes in the system. You can replace any RPM on the system, so you can replace any component. If you want to have some, so for example, fixes systemd, you could replace that and reboot your system and make sure that everything works. If, for example, you're working on fixing things there, and the interaction with KDE somewhere. But you could replace any part of Plasma desktop and do the same. You can replace that live too, so you could apply the change, like restart your session, and that's it. You're good to go. There's no constraints there. It's just essentially there are a lot of tools to make that available still for developers. So it's immutable, but you still get to change it. It's just you have full control of all it changes. And for whatever reasons, it's development. Sometimes we make mistakes. If you want to go back to the version that's stable, that should be working, then you can do that. You can either revert that change that you've made live, or if your system crashed, for example, if you had an issue, if you just reboot, you just go back to the stable version, and that's it. So there's no rolling back packages, changing, or having a broken system. Essentially, you're never in a broken state. It's either working or you just go back to the previous version. That should be working. And for Flatpaks, it's a little bit of the same, essentially. So rpm-ostree is just for the system, and Flatpaks, in Flatpaks, you can have any environment, any frameworks, any version of Python, or any version of whatever you want installed, and any framework, and you will have that independently of what's installed on the system. So you don't get to, you don't have any conflicts of whatever when you're developing in Flatpaks, because you just get libraries from the framework, for example, if you build a KDE application, and you don't worry about the conflicts about in a system or user missing dependencies, something like that, because everything is packaged as a single zone and will be shipped as is. So yeah, it's really liberating to have that in Flatpaks, and it makes it really powerful. All right, so okay, so we want to make a great experience for users, testers, developers. So okay, well, in Fedora CoreIgnite, do we actually have applications? Because for most of the operating system, we need both. We need like the system, and we need applications, of course. Well, the story here is still in progress. So essentially, we already have Flatpaks for Fedora. So on KinoIgnite, you install most of the applications as Flatpaks, and you can already install most of the applications that are available as Flatpaks from Fedora. So right now we have a good selections, but unfortunately we don't have KDE applications yet in Fedora because we're still missing some couple of tricks to make them work. It's still in progress. You can follow the status here in the issue. And it's planned for Fedora 35. I'll try to make that happen for Fedora 35 with the Fedora KinoIgnite release, of course. The main idea here is that once we'll get all the little things tweaked and working, we'll get all the already packaged application from Fedora, KDE package application in Fedora on KinoIgnite, essentially for free. So we'll get a lot of them straight out of the box working. The main thing to remember is that they will be the same version as the one package in Fedora, because essentially they will even though they're not strictly built from RPMs, it's the same recipe. So you will get Flatpaks that are essentially really looking closely alike to the RPMs ones. And it's always guaranteed to be free and open source software, because Fedora is about free and open source software. But then in the meantime, it's good. We already have a lot of KDE applications available on FlatHub. So on FlatHub, you get a ton of applications. I don't even remember the count of the current number of applications available on FlatHub, but it's high. You get either, well, a lot of them. And we quickly expanded the list of KDE applications available on FlatHub. You can search for all the KDE applications there. And we try to follow always the latest upstream release. So they get updated really, really, really fast when the releases are made. Essentially, it's on the day or the next day. And FlatHub is a great place to do a lot of things. It's a great place to fix applications and work with upstream KDE application developers to fix the application that sometimes don't really work well with the Flatpaks unboxing model. So some little changes are needed to make them like really work, or like pretty, I would say. And yeah, there's a lot of small tasks that are easy to get started on, that are there for packaging either existing applications or to fixing some display issues for some, or things like that. So if you look at FlatHub, right now we have like a ton of apps on FlatHub. This is just like the landing page with some popular applications. So it's mixed. There's both on FlatHub free and open source software and proprietary software. So you get to pick which one you want to install, but it's just to be aware of that. And if you search for org.kde, you get KDE applications, which are of course free and open source software, but they may come with additional specific software that's sometimes restricted in some places, such as FFmpeg or things like that, for video codecs or audio codecs. All right, so I'm good on time. So let's see what's the future of Fedora Kinoite. So the idea is, okay, that's what's going to happen in Fedora 35, in the Fedora 35 timeframe. We're really close to close at that, because I'll show you a running Fedora Kinoite instance just after that. But what's coming next? So essentially the plans for the future is that we want to be the best platform to try the next version of KDE. So either KDE Plasma Desktop or the KDE apps. We want to make sure that users, developers, testers, everybody can feel safe, like testing the next version of those packages, those applications, easily using Kinoite, while at the same time keeping a working and stable desktop environment. That's like top goal. So the first one is we want to make the Plasma beta releases available. So right now on Fedora, on the ROAD branch, we always take the latest betas, the latest stable versions, but the stable version will always be a little bit behind, of course. So yeah, we want to make those available in a different way, and we want to also make KDE applications like pre-released or nightly Flatpaks of KDE applications easily available to users there. So that's both work like in Fedora Kinoite and work upstream too. So we want to work with upstream here to make sure that everything done upstream to make application work in Flatpaks will be working well. So on the there's already upstream KDE testing versions of nightly versions of KDE applications, so that's good. And I'd say it just needed a little bit of polish to make it work well. But the main thing here, so for on the Fedora Kinoite side, is we're bringing to users the like beta versions of KDE Plasma Desktop really soon, really fast for testers on stable branches. And this is what we want to do in the short term. So have multiple delivery streams. So right now you will have essentially a delivery stream for each branch version of Fedora. So Fedora 34, Fedora 35, and 36 coming next in 6 months. And what we want to add is essentially a new versions that will be Fedora stable. So the current stable version plus on top the beta versions of the KDE Plasma desktop. So you will get like a really strong, solid, stable foundation like systemd, the kernel, Mesa, the graphics stacks, and everything, Firefox. And then on top, you will get like the beta Plasma desktop available, or the nightly Plasma desktop if there's no beta, and you can just try that. And so essentially, you don't have to fear that, for example, there's a bug somewhere in the file system driver in the kernel in this development version, because it's still a stable kernel. You're just using like the nightly Plasma desktop. So if things crash, usually it's just your system crashing and not everything on the system, and that should be fine. So yeah, that's like what we want to create, like this specific version that makes it really easy for users to test the latest Plasma release on a very strong, stable version of the system. And I think that's something that does not really exist today. Yeah, we want also to make sure that everything gets tested before it gets released. So right now we need a bit of mix, because we do testing, but sometimes things go to users, and we still have some part missing around testing, and we want to improve the testing here. Yeah, and essentially that's it for the main thing we want to bring, and that's a big one, because like enabling users to easily test the next versions is like something without having to create virtual machines, have a new laptop on the side to do the testing, but like actually do the testing live is a big thing. All right, so here's the short summary of everything. Well, we still don't have a logo. It's still in progress. There's an issue to track here. I'll share the slide somewhere. Well, the slide should be shared somewhere. Yeah, if you want to join us and help us do on that journey, we're working essentially in the Fedora KDE SIG, and we're working closely with Upstream. We meet every week on Monday. Usually we are 30 friendly bunch, so feel free to join. Yeah, you can try right now official development builds of Fedora Kinoite. All the instructions are there. It's on the Fedora infrastructure. And if you want to try stable versions of Fedora Kinoite, so an official one, non-official one, the one that I built myself, you can go ahead and try in this link of the Fedora magazine article. And yeah, I think that's time for a little bit of a demo. So let's see if this works. I think I'm good on time. I still have 5 minutes, something. And I can't hear anything, so because probably need to fix my sound. Okay, so demo.
Hey, Timothy, can I offer any help?
Yeah, I'm trying to share a window. I'll have to switch presenter to another browser. Should be fine. Okay, joining back. Oops, sorry. Can you switch presenter mode on the new one session here? I have an audio, please. Thank you. Great. All right. I'll take the first questions if we have one right now. Well, I try to figure out how to share things here.
Sure thing. So it looks like we have a couple. The first question is, when will we get Keynote for Plasma Mobile?
Oops. I don't seem to be... Oh, do you hear me? Sorry. Oh, my bad. Sorry. I'm back.
Okay, well, our first question is, when will we get Keynote for Plasma Mobile?
Yeah, this is planned. This will come when we have all the Plasma mobile application and changes a little bit of tricks into Fedora. I think this packaging in progress for that.
All right. The other question we have is, are you using Keynote as your usual operating system? If not, what would be missing?
So yeah, I am using Keynote on my main laptop and planning to switch my second computer to it once it's released in Fedora.
Awesome. Can I offer any helping to get that demo up?
I'll switch brother again. Okay. Could you? Yeah, not on the other one, please. Sorry. Yeah, thank you. Sorry, it's a little bit of a mess because multiple. All right. Yeah, one should be better. I'll try and resize that so that we get only this interesting part on the screen. And yeah, so this is essentially Fedora Keynote. It's not squared, but yeah, that's twisted. Strange. Oh, that's extra weird. Yeah, all right. So it's just regular KDE desktop. Let's forget about that. I'll share something else. I actually share my laptop, which is running Fedora Keynote. So yeah, here I'm on, it's my laptop, and I'm running Fedora 34. So it's the unofficial version of Fedora Keynote. And yeah, so you can see here, I have two versions running. you have two versions installed. So always at all times, you usually have two versions installed in the system. So the first one here is the version I'm currently running. It's marked by a small dot on the side here. And I have some packages installed on top of this version. So we have Chromium, have Chrome, HTOP, and things like that. And Vim, for example. And there's a second version underneath, which is the previous version I had built before. So it's this one from last week, and this one is from 2 weeks ago. And yeah, I could just go back to the previous versions if there's any bug in this current version. And I'll do a build like on Monday something, and I'll simply update the new one there. So that's essentially rpm-ostree, that you manage your system and you have one image with all the components, the KDE, desktop, and things like that inside. And then you get Flatpaks. So if you go take a look at Flatpaks, I have here a lot of Flatpaks installed. So I have Slack, Spotify, so proprietary apps. And at the same time, I have Inkscape, for example, open source applications, and some KDE applications there that are installed from FlatHub. So if I launch Dolphin, it will run. Yeah, I need this to do org KDE. Dolphin. Oh, I have not Dolphin installed. Yeah, I have Dolphin installed. It's just with a small d. Yeah, so essentially, when I run Dolphin here, it's Dolphin run as a Flatpak. So it's the latest version of Dolphin, even though I don't have this version on my system, because here we're running like 21. Where is it? 21.4.2, and if I run the system Dolphin, so the one that's currently installed on my system, it's a little bit behind because we have not updated the version in Fedora 34 yet. So I can run both actually. I could start the Dolphin, the classic Dolphin 1, and it's just fine. I'll have the version from the system and the one at the Flatpak here at the same time, and they just look absolutely the same because essentially the integration is really good with Flatpaks, and you don't get to see much differences there. And we've got a lot of other applications. We've got the calculator, the image viewer, it's already there, the extractor, and yeah. And the classic ones like LibreOffice, Firefox, Thunderbird, and things like that. Yeah, I don't know if, what should I show you? On the desktop here. Yeah, essentially it's Fedora and it's a KDE desktop, so there's not much to show because it's basically behaving in the same way. So right now it's called Silverblue, but this is just like a preview version. And yeah, and if I was running the Rawhide version, you will get the exact latest. We're right now on Rawhide. We are using the Fedora 522, the KDE 522 releases that we have. 522.1 release, the latest one, built and available, that will be shipped to Fedora 34 in the coming weeks. Right. Do we have any questions left?
All right, it seems we have a couple.
Oh, great.
Does KDE apps come from FlatHub by default or from Fedora Flatpak remotes?
So by default, it's only Fedora because we want to make sure that only free and open source software is available by default. And then you can have FlatHub and get anything from FlatHub.
All right. The question I see is, how do you handle things like the, I'm just going to spell this out, NVIDIA driver?
Oh, yeah, the NVIDIA driver. So you can get that installed easily. It's working now. It's been working for a couple of releases. You can get that installed on top of the image, and it will work. Essentially, it will rebuild the kernel driver for every new version you deploy. And yeah, that's working. I don't have one NVIDIA card right now, but I've did testing and it works.
Great. Well, thank you.
Yeah, thank you.
I hate to say it, but that is the end of our time. And thank you so much for being here and presenting.
Thanks for having me.
Please feel free to jump back in the chats and chat away, answer any more questions that come up.
Sure, will do. Thanks.
Thanks. Have a great rest of the day.
You too. See you.
All right, everyone. Our final talk in track 2 for the first session of today is closing the distance between CPU and GPU. And that is to be presented by Arjen. You hear us, and would you like to join me up on stage?
Yes.
Hello.
Hello.
Welcome. Well, I'll let you take it away and
All right.
have a great talk.
Thank you. So, hello everyone. My name is Arjen Hiemstra. I have been involved with KDE for a pretty long time. Currently, I'm working at Blue Systems. And one of my interest areas is graphics related, graphics programming mostly. And well, that's actually what today's talk is about. I've been working on some very much graphics related problems for the past 2 years and have found some interesting developments there. So this talk is about distance fields, assigned distance fields specifically. But first, I would like to explain some concepts behind, well, everything that is being, or everything that underpins these distance fields. So for starters, the current major APIs that use for 2D rendering on well, everything basically are based on a model that's called the PostScript model. This model has been developed in the end of the 1980s, and essentially it models a 2D plotter, and it has a list of commands where you go, okay, move from point A to point B, then draw a line, then do something else. And that's how you end up rendering various shapes using this PostScript model. And as I mentioned, it's been the major API or the major model used by systems such as QPainter. Also Canvas on the web is using this, and in fact SVG models is modeled based on this, which is all nice and everything, but then we have a different thing these days, which is called the GPU, which is so ubiquitous these days that everything, even mobile phones and a whole bunch of embedded systems even now feature this GPU. And it's a chip that has been designed for something completely different because it was originally meant to accelerate 3D rendering. And because of that, it's designed to be massively parallel. So it's designed to process individual points and everything in a parallel way, which is completely different from how your CPU handles things, actually. And a development that has been around for a long time now was to be able to execute different small programs on the CPU to do various tasks, to render this, to render things on screen. These programs are called programmable shaders, or shaders usually, which are these days written in some kind of high-level language. For example, and what I will be using in the rest of this talk, GLSL, which is the main shading language of used by OpenGL. These shaders will be executed during different stages of your rendering pipeline. So, for example, in this example, I have a vertex shader which converts points that you provide to the API to something that can then later on be rasterized and rendered using the fragment shader, which I've also illustrated here. Which is it's a different way of handling things, and it comes with its own complexities. So, signed distance fields. As I said, we have this GPU, and so, but we have a problem here, because it would be really nice if we can use this GPU for rendering much more complex 2D items than so that we don't stress our CPU and leave that up to do other tasks, or because we simply have a GPU that's more capable of doing this. However, the PostScript model, as I illustrated before, is very much a serial process. It's executing tasks that go, okay, move, line, all that stuff, and every previous step actually depends on, or every step depends on the previous step. So this is a problem for a GPU, because the GPU is actually really, really bad at doing serial tasks. It's way better at doing massive parallel tasks, because that's how it was designed. Which means that we kind of need a new rendering model if we're going to render 2D on the GPU. And this is where distance fields come in. So signed distance fields are, at their most basic, they are math that describes the distance from a point to a shape. In this example, I'm using a circle, which is the most basic distance field that you can get. And the distance field for a circle is basically the length of the point to the center of the circle minus the radius of the circle. Now, this is a bit complex if you're looking at it from the point of math. However, it does provide us with some properties, because what we can do is we can sample that function, that mathematical function, at various points, get a distance out of that. And then with that distance, we can calculate other effects. So, for example, here, if we have 3 different points in this distance field, where we have one point, A, which is on the edge, where the distance is 0, and then we have B, which is outside of the shape, which has a different distance, and then we have C, which is inside the shape, which has also a distance value. And you'll notice here that this is where the signing comes in, because B is outside the shape, so it has a positive value, whereas C is inside the shape and it has a negative value. So this sampling is very useful because we can determine where things lie. However, and this is actually where the GPU comes in, because our fragment shader is effectively capable of sampling this distance function for each pixel on the screen, which is something that basically comes for free if you're using a GPU, because that's what your GPU does anyway for the final rendering step in your pipeline. It needs to convert your points into something that's rendered on screen, and there's a step called rasterization, which turns these points into a grid of individual pixels, and then for each pixel, it will execute your fragment shader to determine the final color. So if you have a fragment shader that contains a signed distance field, you can you will get a sample for each pixel, or you can sample this distance field for each pixel. So in this case, continuing with the circle example, I have converted the math expression to something that's something in GLSL, which is in fact fairly simple to do, at least for a circle, because you can GLSL simply has a length function, so you can get the length of the point of the sample, and then you subtract the radius, and you get the distance to the shape. In this case, I'm rendering directly the distance to this point, so you get a nice black blob. Of course, that's not very useful, so we need to do some extra operations with this distance field, with this distance value. And so, as said, distance fields, signed distance fields specifically, are signed for, and which means that we can make use of this property to determine whether we're inside or outside of a shape. In this case, if we check, hey, is my distance bigger than 0, then I know we're outside of the shape, so we don't need to render anything, and we can just return a transparent color. Whereas if we're inside the shape, we can actually return the color that we use or that we want the shape to have. Well, that said, this test is very binary. So it's not, I don't know if it's clear in the picture, but it leads to some artifact that's called aliasing. Because right now we're saying either it's the pixel is inside the shape or it's outside the shape, and there's no, since we're rendering in a grid, we get a grid as an output, which doesn't lead to very nice shapes. However, since we have a distance, we can make use of that distance to improve this result. Because rather than just saying binary, hey, inside or outside, we can actually use the gradient from the distance to perform anti-aliasing almost for free. As an example here, where we previously simply checked the distance, now we are doing a mix operation using the distance with a multiplier because we want a very short curve, and then based on in this case a linear interpolation between transparent and our shape color, we render the shape, which means that at some point close to the edge, rather than having a fully transparent or a fully colored pixel, we get a pixel that's only like half of the color, which is what effectively anti-aliasing is. So that's all nice and everything, but of course, rendering just circles isn't very useful unless you really, really would like to render circles. So luckily, there are many shapes that can be expressed as a distance field. And next to that, there are also many operations that can be done on these distance fields to achieve different results. As an example here, we have the basic transformations, translate, rotate, scale, which are already helpful. But then there are 3 operations which are similar to a concept called constructive solid geometry, which is something that CAD uses a lot, which allows us to combine these shapes into different results. So listed here, these examples are union, which combines both shapes. We have a subtract, where we subtract one shape from another, leading to a new result. And then we have intersect, which provides an intersection between 2 shapes. And finally, we have a few operations that are unique to sign distance fields, which is annular in this case, which is best described as using or outlining the current distance field. We can easily round shapes and finally we can just take the outline, because wherever the distance is 0, we know that we're exactly on the edge of the shape. In this example, outline and annular don't really provide different results, but outline is useful for expanding or for creating different shapes. So we have this technique called distance fields and this is all nice from a theory point of view, but what practical use does it have? Well, I started with this entire thing about 2 years ago because I had a specific problem to solve. In a traditional GPU rendered way, you end up rendering a circle is actually somewhat tricky because your GPU works with points and lines between them, and this means that it doesn't know anything like curves or anything. So this means that if you want to render a circle, you need to approximate this circle. You need to come up with some way of effectively faking the circle. And this is, for example, what QtQuick currently does. When you have a rectangle with rounded corners, it will use geometry to approximate the circle. However, if you can actually test this out. If you have a QtQuick rectangle at a very large size, you will actually end up seeing the result of this approximation. And I don't know if it's visible in the image, but you end up with straight edges that approximate this circle instead of an actual circle. So for my problem, or for me, this was a problem because I wanted to render something even a bit more complex, which is pie charts. And a geometric approximation of a circle is easy enough to do for an actual circle. However, if you're rendering a pie chart, you have multiple segments of circles, or not even full circles necessarily. You could actually have segments of a torus. And that makes that geometric approach way more complex. Whereas if we use design distance fields, we can suddenly render actual circles, actual shapes, without needing any trickery for approximations. Because another problem with the geometric approach is actually that those lines are, by default, you will have artifacts, anti-aliasing artifacts. So you need to add additional approximations, additional tricks on top of that geometry to actually render a nice circle. Whereas our SDF, as seen, it provides a very natural way of rendering circles. So I discovered this while researching this topic, and then realized, wait, this is great for doing pie charts, because we can actually have a assigned distance field where we have each segment as its own distance field. We render that segment, we need no approximations, because we can feed the data to the GPU. The GPU will go, okay, for each pixel, is this within the segment? Yes, no, using all the gradients and everything, and then we can get very nice looking pie charts, fully accelerated on your GPU. So this proved, I experimented with this, and this proved quite successful. My initial implementation of this actually used a number of actually used a bunch of the CSG operations that I mentioned before, because it used a circle and then cut away the parts that are not, so it ended up with a segment of a circle instead of using the full circle. Later on, I found a distance field operation, a distance field function for a part of an arc like this. So that became unnecessary, and the result was better that way. But even the initial implementation was already better than an approximation in geometry would have been. So using that information from the pie chart, I went on and figured, well, what if we do the same with line charts? Line charts have similar problems. You have lines that will have aliasing problems if you use geometry for them. You want to be able to vary their thickness, so you can't just render points or render line segments easily, because you need to be able to control what these line segments look. So you would need to generate geometry for the entire line segment, which becomes complex rather quickly. That said, the distance field behind the line chart implementation turned out to be a bit more complex as well, because it's hard to, it's tricky to make a set of line segments this way. So what I ended up doing instead is that rather than trying to chain a bunch of line segments, because then you lose information about what is above or below the line, this actually renders using a polygon. effectively what it does is there is a polygon that is rendered using about this shape, and then if we need to fill it, we can just fill that entire shape, and using some of the other operations like the annular and outline, we can get just the line on the side and render that as well. So this is all it's all been implemented in the K-QuickCharts framework, and there's a bunch of other features there that I'm not going to into right now because those aren't related to distance fields. The distance fields do power two of the main chart types, though. Another use case for distance fields came later. Kirigami has a concept called cards. They used to look approximately like this, which is okay visually, but there's actually a bit of an element missing here because these use sharp corners, whereas a lot of elements within the Breeze style and within our general visual theming have rounded corners. But there was another problem with these because their implementation was rather suboptimal. It's not, you can't see it from the visual result, but in the background, what this did was actually create separate items for each shadowed edge. So there is an item here for the left edge, one for the bottom edge, one for the left bottom corner, and all, etc. And that makes the implementation of this rather expensive. So I spent some time thinking, what if we could replace this entire background thing with all the items with just a single item to render this background? And that's how I created an item that's now called Shadowed Rectangle, which is a distance field of a rectangle with rounded corners that also includes a shadow. Which meant that I had one item that would allow me to render this entire background, including its shadow, without needing any other items, and with a fairly simple implementation in the shader, actually, because it's you need the distance field for the rectangle, but after that, most of the other effects are simple operations on that distance field, or on the distance that you get from the distance field. So this also allows extra features that current Quick Rectangle doesn't expose, like having different radiuses for different corners. Well, with this, I could replace the background of the cards. However, there was a remaining problem because some of the cards have an image in the top. And if we render the background with rounded corners, that's all fine. But if we just place an image on top of it, either we lose the rounded corners on top, or we end up with some rather expensive, needing to write some rather expensive code to cut off these corners of this image. Luckily, again, the distance field implementation provides a fairly simple solution here, because what we can do is, rather than fill the distance field with a solid color, we can query a texture, get a color from the texture, and use that as the color of the shape if we're inside the distance. which means that rather than needing to do a whole complex set of operations to render a shape and use that as an opacity mask to cut off these corners, we can just use almost the same logic as the rectangle previously used, and then use that to render a texture instead. So with that, I was able to recreate or replace the cards with a new background that used the shadowed rectangle and used the shadowed texture implementation to get rounded corners and also a new updated design for the cards, and just generally looked a lot nicer than what we had before that. And well, both of these elements were very important because eventually what I did, or what I was working on, was a new version of our new system monitor for Plasma. And this system monitor is very heavy on charts because almost all the data sources you want to render as a chart. So you don't want to have to constantly fall back on CPU rendering. You instead want to make sure that your charts can update at a smooth frame rate, ideally whatever your refresh rate of your monitor is. So that's what where I put or what I did to make this all possible. The pie charts are provided by Quick Charts. The line charts are provided by Quick Charts, and both use design distance fields for rendering. And then the cards are provided by Kirigami now, but also use distance fields for rendering. So approximately 80% of what's being rendered by Plasma System Monitor here is being rendered through distance fields. Well, and that's where I want to end this talk. I want to have a special thanks to, I'm going to fail on the pronunciation, but Inigo Quiles, who has a whole set of articles about distance fields on his website, and which is what most of this work has been based on. Any questions?
Well, yes, thank you so much for your presentation. We do have a few questions. The first being, might be misspelling, but is this shader approach fully portable to Qt's new RHI API, or where do we have to be careful?
So Qt RHI in Qt 6 requires using Qt Shader Tool, which wasn't available until Qt 6 was released. I haven't done actual porting yet, but the shaders, all that's needed is porting the shaders to Vulkan GLSL instead of OpenGLSL, and then building this with Qt Shader Tools, and then we should, or as far as I know, we should be able to build using Qt 6. So as far as I know, it's fully portable, and there isn't any real limitations there. In fact, Qt 6 RHI actually makes things easier, because right now we have to maintain a separate set of shaders for core profiles and a whole bunch of other tweaks just to make sure that we can support a various set of OpenGL APIs, whereas in Qt 6, Shader Tools will take care of all that for us.
All right. The next question, can we do bezier curves with signed distance fields?
Bezier curves, yes, there is a distance field for Bezier curves. That said, those implementations get expensive rather quickly. So it depends a bit on how many of these Bezier curves you want to render, whether that's feasible or not. Alternatively, what I do in Quick Charts for the line chart smoothing is that actually the processing of the smoothing is done on the CPU, and then this is rendered on the GPU as individual line segments.
One final question for you. One of Qt-Quick's text renderers is also SDF based, inspired by Valve SIGGRAPH paper that popularized the technique. Is this usage broadly similar, or has the SDF state of the art evolved?
So I do know that the distance field rendering of Qt's text is indeed also based on this. The main difference there is that the text rendering uses pre-calculated values for the distance. It will generate a texture that encodes the distance for each point in the texture, which is mostly because the actual text shapes would be way too complex to render directly on the GPU, because you have all these features of fonts that you need to take care of. And as basically they're a large collection of very complex Bezier paths, which, as I said previously, you can do, but it gets expensive. So they're mostly similar, with the side note that distance field text is using pre-computed distance fields, whereas what we're doing here is using the actual distance field function for rendering, which allows us to scale things much more easily.
Great. Well, that is the last question we have.
All right.
I hope you enjoyed giving your talk, and I think the audience seemed to have enjoyed listening.
Good.
I want to thank you again, and
Yes.
I want to let everyone know. Oh, go ahead. Sorry.
All right. Goodbye, then.
Bye. Thanks. For everyone still hanging on in here, we are going to take a break for the next few hours. Please enjoy your break. We will be back at 1700 UTC with another round of sponsors talks, and then coming back into this track too for Marco Martin's Plasma Internals and Christian's Qt Quick 3D, I think it would be David Edmondson's Addressing Wayland Robustness, and Igor talking about DevTrack, the next generation. So again, enjoy your break. We're going to come back at 1700 UTC, and we will see you then. Thanks so much, everyone.